Hello and welcome back to the video lessons for outcome 30.6. In today's lesson, we are going to talk about something called a factorial. So on our rubric, we can find it at a level 2 where we evaluate different factorials. And then as we move on, we can find it in the level 4 where we simplify factorial expressions and we solve factorial equations. So again, our goal is to use factorial notation. At this point, you're going to want to go onto your calculator, and you want to look for a button that looks like an exclamation mark. Whenever we talk factorials, that is what a factorial is. Again, it looks like the exclamation mark. So here's our first example. It says, show the different single-file lines that are possible when Chase, Carly, and Arland line up at a cashier at a fast food restaurant. So how many different ways could they line up? Let's do it with a list. So it could go Chase, Carly, Arland. It could go Chase, Arland, Carly. It could go Carly, Chase, Arland, Carly, Arland, Chase. It could go Arland, Carly, Chase, Arland, Chase, Carly. There are 6 ways. In the last lesson, we learned that we can represent those ways using the fundamental counting principle. So we have 3 people. We have 3 options for the first spot. Once that person is selected, I have 2 options for the next spot, leaving me 1 option for the last, and I still get my 6 different options. In this lesson, we are going to look specifically at what happens here. Again, noticing how the number goes down by 1 each time. That's going to become really important as we start talking about what a factorial is and how we can use it. So here's another example. Again, we can use the fundamental counting principle on it. So it says Naomi volunteers after school at a daycare. At 4 p.m., she lines the kids up to get a drink of water for the fountain. How many different arrangements of children can Naomi create for a lineup if there are 6 kids? So 6 kids means there's 6 tasks. I have 6 options for the first spot, 5 options left for the next, then 4, then 3, then 2, and then 1. So if you multiply that through, you have a grand total of 720 ways. Again, I want you to notice that how each time the number of options goes down by 1. Right, I start with 6. This one is 6 subtract 1, giving me 5. This one's 5 subtract 1, giving me 4. Right, then 4 subtract 1, then 3 subtract 1, then 2 subtract 1, all the way through. So what is that? So the first new word we have today is a permutation. Permutations are just arrangements of objects in a definite order. So if I have 2 objects A and B, there's 2 different permutations of them, AB and BA. Whenever you hear the word permutation, you should be thinking order matters. Okay. So in questions where there's permutations, especially those questions where you use all of the objects, we are going to use factorial notation. Again, factorial notation means I'm going to be using that exclamation mark type button on my calculator. Basically, it's just a product of consecutive descending numbers, where you're always going down by 1. So we'll get to more questions with M later, but let's just look at the 4 down here. 4 factorial means I start with 4, then I go down 1, get 3, go down 1, get 2, go down 1, and get 1. As soon as you hit 1, you stop. So if I were to do, let's say, 7 factorial, it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. As soon as you hit 1, you stop. Factorials do not work if it's a negative. If that does not work. Factorials do not work for fractions, they won't work for decimals, they only work for nice whole numbers. So the first part of this is just to evaluate the following. So when you do these questions, you have two options. The first option is to simply punch in 10, so 10 factorial, times 9, times 8, times 7, times 6, times 5, times 4, times 3, times 2, times 1. However, if you know where your factorial button is, you simply just have to punch in 10 factorial, and you will get the answer, which is 3,628,800. So again, B then is along the same lines. Again, if you know how to use your calculator, it's a lot faster. So you have 12 factorial, which is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over the bottom, which is 9 factorial. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm getting really annoyed doing this. Times, and then 3 factorial. 3 times 2 times 1. But again, if you know where that button is, you can just punch it in. So you punch in 12 factorial divided by 9 factorial divided by 3 factorial. Or you punch in 12 factorial divided by, and then in brackets, 9 factorial times 3 factorial. At the end, you get an answer of 220, no matter which way you do that. All right, we have one more example where I'm just going to use nice integer numbers in the example. So it says, express the following as a single factorial. So the next one is 8765431. Notice how it gets all the way down to 1. When it does, that's a factorial. So the starting number is 8, that is 8 factorial. The next one is 12, 11, 10, 9. And then there's the factorial, which means that it's 12 times 11 times 10 times. Now the factorial starts at 9, and it goes down again. Factorials mean they go all the way down to 1. So now my new starting number is 12, so this is 12 factorial. Now, quite often students see the ends, and they get worried. Ends are just the exact same idea as numbers, just that you have ends. So my starting number is n plus 3, which means my next number then would be n plus 3, subtract 1, which is n plus 2. This number then would be n plus 2, subtract 1. This number would have been then n plus 1, subtract 1. That gives me n. This one then is n, subtract 1. And again, notice how it goes all the way down to 1. So my starting number was n plus 3, and then it's a factorial because it goes all the way down to 1. So once we start hitting these ends, as opposed to numbers, we're hitting level 4 type questions. So the next one are just some simplifying. It says simplify because there is no equal sign in those expressions. So the first one is an n plus 3 and then an n plus 2. And then that n plus 2 has a factorial. So the first thing I'm going to do is I'm going to start with the first one, which is n plus 3. And then n plus 2 is my factorial. So that means I start with n plus 2. And then my next one then is n plus 2, subtract 1, which is just n plus 1. My next number then is n plus 1, subtract 1, which is just n. And you can do this on forever and ever and ever, but because it's a factorial, my last one's going to be a 1. So again, my starting one is n plus 3, so this is an n plus 3 factorial. Now there's definitely going to be questions where you have a factorial on the top and bottom. So all I'm going to do is use my factorial ideas on both the numerator and denominator. So n plus 1 means that the first thing I got to do is n plus 1, subtract 1, meaning my next number, if I keep going, would have been just n. The next one then is n subtract 1, which is just n subtract 1. My next number would be n subtract 1, which is n minus 2, forever. Right? It's going to end up at 1. Now on the bottom, I start with my first number, which is n minus 1, and then I subtract 1. I got n minus 2. The next one then is n minus 2, subtract 1. So negative 2, go back 1, or negative 3. And again, that will go on forever until 1. Again, you can do more, but I usually just do a couple, and then I see if there's some overlap. So do you notice that as soon as I hit n minus 1 here on the top, it meets up with what's on the bottom? Then everything after it is going to end up being the same. So I can reduce those right out. And then all I'm left with then is that n plus 1 times an n. If you had to multiply that, just remember your distributive rules. You multiply into the brackets. N times n is n squared. 1 times n is an n. And that is just it being multiplied out. Same answer, just different ways of expressing it. So the next example then is just one step further, where you're given now an equation to solve. You have a factorials on one side, and it needs to equal 90 then on the other side. This piece right here just means that my n has to be an integer. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So I start with n factorial, means n is my first one. My next one then is an n minus 1. Right, so n minus 1. The next one takes n minus 1 and I subtract 1 off of that, so negative 1 go back, 1 is n minus 2. The next one would be n minus 2, go back 1, I get n minus 3. And that would go on forever until I hit 1. I do the same thing now for the bottom. I start with my first one, which is n minus 2. Then I would go n minus 2, subtract 1. Now I'd get n minus 3. Then I would go n minus 3, subtract 1. Get n minus 4. And again, that would go on forever until I hit 1. So just like the previous question, I now look for things that overlap. They start to overlap at n minus 2. So that n minus 2 cancels, the n minus 3, it would continue to cancel out until the end, leaving me with, right there, I'm left with an n times an n minus 1 equals 90. Now at this point, you just got to look at what this thing represents here. This means that I have two numbers that multiply to 90. When it's an n and an n minus 1, that means that one of those numbers is one less than the other. So if you can think about this right away in your head, that's great. You can figure out your two numbers. But if you can't, just start making a list. So what two numbers multiply to make 90? 1 times 90, well, they are not one less than each other. 2 times 45, not one less than each other. 3 times 30, again, that's a no. 5 times 18, again, another no. 6 times 15, another no. 9 times 10, ding, 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 ding. We have two numbers that multiply to make 90, and one is one less than the other. So if we have an n times an n minus 1, the bigger one is first, and then 10 minus 1, which is your 9, is second. So that means that my n is 10. And again, that is a level 4 type question. So again, anywhere where you see an n, that is a level 4. It is now your turn to try some in practice number 2.